I think well, hopefully I mentioned this previously. You can't just write a line in 3 dimensions as like y equals something x plus something else, or z equals something x plus something else, because we have 3 variables to play with. If you write something as, like, for example, y equals 3x minus 2, that assumes that that's true for all values of z. So you're shooting up the z-axis and down the z-axis for all values of z. So it's going to create a plane. If you address x and z in your equations, so z equals something x plus something else, that's assuming for all values of y. Right? So we have to define it in some other way. So what we do is we define it in a parametric sense. Right? So that requires us to address the x, y, and z values that make up a line, but in terms of some parameter t. So we've already kind of dealt with this a little bit when we were finding solutions to systems and then writing it in vector parametric form. It was kind of along these lines, but we're kind of taking it in a different direction now. All right, so define parametric equations for a line L that contains a given point P sub O, which is XO, YO, ZO. So I'll put that, I guess, over here. That's parallel to a given vector ABC. All right, so let me create the parallel vector, because that vector is going to start off at the origin and be parallel to the line. Let me do it in a different color. Let's double check. Use the displacement vector between the given point PO and the arbitrary point P. So it could be any of these. This could be P sub 1, P sub 2, P sub 3. But then somewhere down the line, you have P in general X, Y, Z. It doesn't matter where we're defining that. You can put it anywhere you want. I'll put it at the end just to make it feel okay. Right, the displacement vector between these coordinates has to be parallel to this. Right? So the displacement vector. So we'll start with that. Displacement vector is the difference between 2 points. So it's basically saying P minus P sub O. Has to be some scalar to vector V. Right? Because we know it's not the same length. But we also know that it has to be some multiple of the length of vector V. So, you know, pick a constant designator. I'll call it K. All right, the difference between the two would make, the difference between 2 points would make your displacement vector, which would be x minus x sub O, y minus y sub O, z minus z sub O. Oh, dang. I just can't stop myself. Sorry. I calc 3'd it. X minus x sub O, y minus y sub O, z minus z sub O. Is equal to k multiplied by ABC. All right. So one thing we can do is kind of itemize it. Say something like, for example, x minus x sub O equals Ka. in which case x would be equal to x of O plus Ka. Now, we want this to be some kind of function. We want to be able to vary the location along the line. We don't want it to be some static value. So K typically represents some constant, some unknown constant, 2. But if I want it to be completely variable, I want to use some variable designation. I suppose you could let K be a variable. But typically we let T be the variable that we're referencing because parametric equations very often reference time as the variable. So this gives us the foundation of it, but we kick over and use T as the multiplier of A, B, and C. Right? But anyway, that gives you a sense of where the first component of your parametric equations come from. Now, to kind of make the connection between this and what we've been dealing with in the previous unit, we have our parametric equations, but let's get it into a vector form. Vector form would be x, y, z equals x sub O plus TA, y sub O plus TB, z sub O plus TC. Which could expand out to become x sub O, y sub O, z sub O plus t times A, B, C. Which hopefully would look somewhat familiar. Kind of looks like a particular solution to a system. And that looks kind of like a general solution, sort of like the homogeneous solution. All right, so that's your connection to what we've been covering. But we're sort of going the other way. We're building the equations from the ground up rather than finding, here's a plane. Because when we were dealing with like a 3x4 matrix, something x1 plus something x2 plus something x3, we were finding the intersection or intersections, but in most cases intersection, between planes or among planes. And so when we're putting our answer in parametric form, there was a reason for that. We were actually, in most cases, writing the equation of the line that represented the intersection of two planes. Because if you take two planes and intersect them, well, this doesn't really do a good job, but there is a line that would illustrate that intersection between those two planes. All right? So finding the equations isn't bad, because all you need is a vector parallel to whatever the line is, right? And because they're parallel, they should have the same basis. Okay, so one should be a constant multiple of the other, right? So basically, if I just find the vector, the displacement vector between the coordinates that are given, I know I'm dealing with something that's at least parallel to the parallel vector, which gets the job done. All right, so that's what I'll start off with. I want ABC -3 minus 1 or 1 minus -3, it doesn't matter. 5 minus 4, 0 minus 1, which would in turn become -4, 1, -1. All right. Either one of those coordinates could become your XO, YO, ZO, but it should be consistent with how you determine your displacement vector, right? But because I'm establishing that this is my, think in terms of your slope formula, x2 minus x1, it's the same idea here. this is really kind of forcing this to be your x sub o, y sub o, z sub o, because based on these changes from that, you should end up with an equation that when you plug in a 1, for example, it should give you the second coordinate based on your first coordinate. Right? So x, y, z would be equal to 1, 4, negative 2 plus t times negative 4, 1, negative 1. Okay, and you could write them out separately if you want, but you could verify. You plug in a 1 for t. 1 plus 1 times negative 4 is negative 3. 4 plus 1 times 1 is 5. Negative 2 times 1. I wrote it wrong. Wait, what did I write wrong? 0 minus 2. Gotcha. Zero minus negative 2. Yeah, well, I know that. I want to write it correctly, though. I always take note of snot rag comments. All right, negative, yeah, good. All right, so parametric equations of the line segments connecting these 2 points, same general idea. So a nice star for you there.